Hey everyone, welcome back to the Foundations in Pre-Calculus 10 videos. In this video, we're going to look at lesson 3 from chapter 4, which is looking at mixed and entire radicals. So before we jump into any examples, we're going to do a quick review first. And the very first thing we're going to talk about is the parts of a radical. That's going to be really important because I'm going to start throwing some terminology at you. And it's going to be really important to understand what that is, or else you might be a little bit lost in some of these videos. So in this picture here, this overall picture here is what we call a radical, and a common one that you guys know is a square root. So typically what happens is that we usually have a number sitting on top of this little hook, if you want to call it, and this one here we call an index, and that one typically tells you what's going on with that radical. So say for example here we're looking at a square root, the index that we typically have here is a 2. So it's telling us that we're square rooting an answer. So we're trying to look for numbers that can be written in terms of an exponent of 2. But one thing that you'll notice is that we never write our square root with the index of 2 there. And that's just kind of like our common little things that we do in math, like when we're multiplying by 1, or when we're adding by 0, or even just writing x. This here actually represents 1x, but we don't write the 1 just because it doesn't make sense. We know that there's an x there, so there's no point in wasting our time in writing it. So typically, we will see our radical for a square root as just the radical symbol. So the number that goes inside of our radical symbol is what we call the radicand. So that's the number that we're trying to break down in terms of either square rooting or cube rooting or whatever kind of index number that we're working with. So now we're going to talk about two different ways we can write a radical, and you can kind of think of this like fractions, except I know with fractions we can write in 3 different ways, where we have the improper, a mixed, and then a proper fraction. But we're going to take 2 of the ideas from those fractions and use that to, and apply it to radicals. So the first one that we're going to talk about here is what we call a mixed radical form, and this one here, if you think about just like a mixed fraction, that one usually has a whole number up front, then some sort of part of a fraction. So what we're going to do is we're going to have a whole number up front, and then we're going to have a radical with some sort of number inside of it. So say, for example, we had 2 cube root of 4. Here we have a radical and then a whole number attached to it. And when we see it attached to it, these are just multiplied. So this is like 2 times cube root of 4. So the other way that we can write this is using entire radical form, and kind of like with fractions, this could be similar to an improper fraction, where we would convert this 2 3/4 into an improper fraction. So here that would be 4 times 2 is 8, plus 3 is 11. So you'd have 11 over 4 as your improper fraction. So here everything is in the fraction. So with our radical, we're going to try and move this 2 inside of the radical. And so typically, in order to do that, when you're moving a number inside, what you have to do is you have to give it the exponent of whatever the index is. So to move it inside, you're going to go cube root of, so it'll be 2 to the power of 3, so match the index, and then multiply by the number that's inside your radical. So multiply it by 4. And then we can simplify this. 2 cubed is 8. And then 8 times 4 is cube root of 32. So just to recap that, so with our entire radical form, everything is inside of our radical. And then with mixed radical form, this is here what we call in simplest terms. So we've moved out all the numbers that we can outside of our radical. So once again, that's kind of just like fractions, where this kind of fraction would not be in simplest terms, but we would say that 2 3/4 is, because we have that whole number, we've pulled out all the numbers that we can, and we're left with whatever our remainder is. So there are benefits to each of these different types of forms. So typically with mixed radical form, this one here shows us our answer in simplest form. And so we can make sure that we pulled out all of our numbers that we can simplify. But with the entire radical form, this one here has the advantage where if you want to compare radicals and see which one was bigger, which one was smaller, then you can clearly see what is happening, because then you just look at which one has the biggest radicand, assuming that they all have the same index. So that is everything for that recap. So now we're going to move on to example number 2 from your notes, where we're going to work on converting between mixed radicals to an entire radical form. So here we're going to write each mixed radical as an entire radical. And our first one here is 7 square root of 3. So if you remember, when we're converting into radical form, we want to move this whole number inside of your radicand. So to do that, you need to give this whole number the same exponent as the index. When you don't see anything there, then you assume it's a 2. So 7 becomes 7 squared, and then times it by the number that's inside your radical. You can go ahead and keep simplifying. So 7 squared is 49 times 3, and 49 times 3 gives us 147. So, and one way that we can check our answers to see if this is right is that we can put square root of 147 into our calculators, and then the decimal number should match what we put in as 7 times square root of 3. We should get the exact same number. And now our last one here is, here we have 2 cube root of 4. So this one here we have a different index, but we do the exact same kind of work. So we want to move this 2 on the inside of our radical. So I'm going to write my cube root symbol. Then I'm going to write 2, and then I'm going to give it the same exponent as the index. So it becomes 2 cubed, and we're going to multiply it by the number that's inside that radical. We can go ahead and simplify. So you have cube root of 2 cubed is 8 times 4, which gives us cube root of 32. So it's actually the example that I did previously in this video. But that is everything here for this video. So just to recap what we did here, we talked about some of our the different parts of a radical. So we introduced some new terminology. We talked about the 2 different types of forms, and we've also looked at how to convert from mixed radical to an entire radical form. So if you guys have any questions, make sure to come see me in class or text me on Remind 101. Thank you guys so much for watching.